Good afternoon. So I know you've been hearing a lot about GIS at the conference today. I'm going to start off with something just a little different. So I want you to cast your mind back about 10 years. And if you wanted to listen to the latest CD from Coldplay or one of those types of bands, what you did was you went to the record store, like a JB Hi-Fi, you bought the CD, you went home, you plugged it into your CD player, hopefully a better one than that, and you listened to the album end to end. What do you do today? Stream it, right? You stream it on a service like Spotify or Apple Music or something like that. What's changed there is quite fundamental in the sense that once upon a time you had a very limited library of music and you had to buy it, you had to store it, you had to even, like if you're like me, you had to put an Excel spreadsheet together to list all the CDs that you've got. That world's changed. Now the world's library of music is available to you and you can stream it anywhere, anytime, on any device. So at Nearmap, we kind of started to think about that and said, well, what if we could do take reality and deliver that as a service so that wherever you are, that digital world could be delivered to your device anytime, anywhere. So that's basically the proposition we started with, so to deliver reality as a service. So what I'm going to do now is kind of take you through what that actually means and how that's delivered and how that could be delivered within the Esri environment. So first of all, you're probably all familiar with 2D aerial imagery and satellite imagery, and that's available as a layer, and you have a base map available within your Esri applications. But what Nearmap did, and we started this about 10 years ago in Australia, is we said it's one thing to kind of go out, fly a county or fly an area, capture it, deliver it to our customers once. That's not really good enough. What we want to do is, when we developed our technology, so that we could capture the Earth multiple times, and we do it kind of up to 6 times a year. So in the last 10 years, we've captured places like Brisbane, Perth, Melbourne, Sydney, etc. We've captured them over 60 times. And so what you're seeing here is because we're capturing that library of information on a consistent basis, what you're seeing here is the transformation over time. The first set of images you saw were actually the developments around Cockle Bay in Sydney. And this one, a little bit of a personal favourite for me, I'm from Perth. This is the development of Elizabeth Quay. And so what you see is that by changing the mindset of how the Earth is captured, so instead of somebody asking for an aeroplane to go out to be flown to capture some imagery and just having it once, instead what we're doing is we're capturing it all the time on spec and delivering that as a service. The big other difference is because it's hosted out in the cloud, whatever device you've got, wherever you are, all that data, both the current imagery as well as all the history, is available. So you can go back through time and find the best image, find out what's going on. Okay, so that's the start of capturing reality as a service. But so actually before I go on, what does that mean for you as Esri users? So what we have done, and we spent a lot of effort in this in the last 2 years, is integrate our content natively with all of the Esri applications. So if you look at it here, this is ArcMap, of course. And you can see there integrated with it, so it's a layer available. So all the other layers of data that you have can combine with the imagery, this high resolution, up-to-date imagery. But if you look in the center panel there, what you also see, and this kind of demonstrates the number of times that we've captured that particular location, you can choose which date you want to look back to. So if you're looking at a change over time, if you're looking at maybe there's a legal dispute about where something entered, you can go back through time. We actually have a customer who is a company called Hydra Max. What they do is they look at all the underground services, so gas lines, water lines, etc., etc. And what they're doing is they look back through time to see when the boreholes were put in for a particular infrastructure. So that history is available, again, available natively through all the Esri apps. So now, 2D is kind of one view of reality. Also just there talking about integration into the ArcGIS online services as well. Okay, so 2D is one way of viewing the content. But we kind of said reality is, in reality, three-dimensional. So what if we could upgrade our capture systems and our camera systems so that, in fact, what you think is a 2D view is actually capturing in 3D. Now, I'm sure you've heard a lot at this conference about 3D and how that can be integrated and how that can be used. But one of the things, this, by the way, is Austin in Texas. One of the things that we are doing that is unique globally, and remember, this is an Australian company, and we're doing this globally, is we are capturing 3D content at a scale that's never been done before. Most other systems use either drones or do a small localized capture or use some helicopters and capture a small area. We'll be capturing all the major capital cities of Australia at scale, updated every year, and we're capturing 68 cities in the US, captured at scale and updated every year as well. So you can see the quality and the fidelity of this content. And what comes from that is, again, what we've done is upgrade our camera system to kind of capture this content at that level of detail. Okay, so what does that mean? Well, actually adding another dimension is more than just giving those 3D fly-throughs. Those 3D fly-throughs, they're cool visualization, but what does it actually mean from a content or usability point of view? Well, we actually think of it as a bit of a journey from 2D to 3D. Obviously, you've seen the 2D imagery. This is actually the Capitol building in Austin, Texas. We just saw, or about to see that in the fly-through. But by the way we capture our content, we're not just capturing looking straight down. We're actually scanning across the horizon. So we're looking at it from all kinds of angles in order to do that 3D reconstruction. What you see here is what we call an oblique view. You may sometimes hear of it as a bird's eye view, but that kind of 45-degree angle so you can see the side of the building. The extra information you obviously get is you know now this is a 2-story building. You wouldn't have known that before. You can determine the height. You can see the kind of relative height of the cupola on the top, but also you can determine the height of the trees relative to the height of the roof of a building. So that information starts to get extracted from the oblique view, and in fact you can even measure the heights of those features in that third dimension. Sorry. Now that's one thing, to kind of see it from the 4 cardinal views. The next thing that we do is we actually give an elevation profile. Now, it's probably a little hard to see in the diagram behind me, but there's a little black line that goes across the top of the cupola. And if you look at the bottom, you can see a profile view. Now, the orange line is from a company that we don't mention at this conference, but it gives you kind of the flat profile. The blue line shows you the actual profile of the building, and that comes from our data. The level of precision that's coming from this is quite unique. And remember, we're doing this at scale for whole cityscapes. So that's useful. That gives you one line of height. But really what you would like is a digital surface model. So here you can see, we call it, whether you're American or Australian, a sun-shaded terrain or a hill-shaded terrain. But basically the colours reflect the height. So it's an X, Y, Z. For every XY point, there is a Z height to determine, so give you basically a digital surface model. Think of it as drapesing across the terrain. But from all of that, of course, what you really want to do is extract real 3D data, and that comes in 2 forms, either the point cloud, and maybe, let me have a look at the screen, it's probably a little difficult to see here, but the density of points corresponds to the density of the differences in the shapes of the buildings. So your clear faces have less points on them, but the trees have a lot more points on them. But then the real sexy view, the one we really like, the one we saw in the fly-through, is, of course, your textured mesh. So where we take the photos that we actually originally started with, put it all the way through our processing pipeline, get the structure of the building, and then paste on the original photo, or a version of the photo of the building. So it gives you lots of options for how to use that. So you say, hey, that's really cool. What do I actually do with that? So let's have a look at some of the use cases of this content. I'm going to talk about 3 or 4 different use cases. The first one, I know a lot of you are in local government, is a development application. So here's a bit of bare earth in Gold Coast, and what we're interested in this particular case is putting a multi-story apartment block on that. So somebody has designed that in an application. You've got, for example, here the building in the middle, and you want to look at what that looks like from within the environment. Now again, there's 3D models that are created all the time. There's 3D captures, but they usually have a small area. What you really want is that data at scale, so you can see what the building looks like in the greater environment rather than just in the narrow environment. So that's the building. So now let's have a look at that now from the developer's point of view rather than from the local government's point of view. What would it look like to be in the penthouse apartment, for example? So this gives you the view, and you can kind of see as we spin around here, this is what the view would look like. And again, by having that broad landscape capture, you can see off into the distance. You can see the hills in the distance. You can see larger buildings in the distance, as well as those buildings that are close to the site. So you now, if you're trying to promote this, whether, again, from the LGA's point of view or from the developer's point of view, you can actually give a perspective of what the view would look like. Okay, another application. This is a telco one. You can kind of see in the middle of the picture there a red tower. That red tower could be a base station for a wireless rollout. Now, some of you may have heard of 5G, and we all had our 3G phones, our 4G phones. Yes, there's 5G coming. 5G will be a very high performance wireless technology. May go on your phone, maybe fixed wireless, but either way, it gives you kind of NBN type speeds when NBN works. All right, so what we're showing here in this particular animation is the red shows where buildings are shadowing that wireless signal. 5G is very sensitive to line of sight. So in this particular case, we can see that because of that tower is quite low, it's getting there's a lot of shadowing from the buildings. We can also see the impact. Yep, there we go. We can also see the impact of that building that we just built. Well, you know the one we saw before? Okay, when we take it away, the signal's there. When we put the building back, we can obviously see the signal impact. Now, that's a very simple example, but if you're a telco rolling out the kind of infrastructure like a fixed wireless infrastructure, you need that detail across a wide area to optimize the base station rollout. Okay, let's now move to a third application I want to talk about, which is a solar application. Again, a very compelling use case for that third dimension. So we've zoomed out of the built-up area into a more kind of light industrial area. Here's a building with some existing solar panels on it. And what we're going to do is put a few more solar panels onto that roof. So you can kind of see them again from the 2D point of view. Now what we're going to do is kind of zoom down and have a look at those solar panels right there. Now, what I'm going to show you here is actually very useful. If you look on the left side of the screen, as I go through this animation, and you'll see... Did I get that right? Yeah, there we go. As we rotate around in 3D on the right side, on the left side you're seeing the original source photos. And see how many times those original source photos that we took change. This is the reason we can do the reconstruction in 3D that we do. We take something like 20 photos of every point on the ground from all different angles as the plane's flying at 4 kilometers and 200 knots in the sky. We're taking all of those photos, and that allows us to do that reconstruction in 3D. Anyway, back to the solar use case. So as we look at this particular example, the panels on the left were the ones that we added. Of course, because we've got the 3D data now, we can actually do solar irradiance calculations. So that depends on the sun angle, shadowing from neighbouring trees and buildings. So as you roll through this, we'll start with the middle of the day, and you can see as the sun starts to set towards the end of the day, the intensity on those solar panels is going down, going bluer. So the orange obviously being more intense, towards the end of the day, less intense, and then as the sun rises again in the morning, greater solar intensity. So again, for the solar industry, no need to go on site, take measurements of roofs, determine angles, put people on ladders. You can actually fully automate the design of a solar installation using this kind of technology. Okay, so that's great. We've got all that incredible content. So what does that mean from an Esri user's point of view? So ArcGIS Pro, of course, handles that third dimension very well. So this data, this 3D data, can be exported in all the various formats that I talked about before, can be exported and then imported into ArcGIS Pro. I actually like the tool here. When I first saw this demo, this kind of height tool, it was really intuitive to kind of use. So you've got this 3D model, you put a point, you've got our 3D data inside ArcGIS Pro, you put a point at the ground level and then kind of raise up that disk that you see. And once the disk gets to the top of the building, it gives you the exact height measurement. It was really intuitive to use, but as you can see, many of the tools inside ArcGIS Pro would work very well with that 3D data. Okay, so I just want to kind of bring us back then again to what are all the various applications. And so I've talked about 3 possible applications: the development application, the line of sight application, the solar installation, and then also showed how to do just basic measurement inside ArcGIS Pro with that 3D data. But again, there's so many different forms going from the 2D ortho view, the 4 cardinal views, north, south, east, west in the oblique views, through to your digital surface model, and ultimately the two forms of 3D outputs. So with all of those kinds of data inside the Esri applications, imagine what you could do with that 3D content if you had reality as a service. Thank you.
It was a nice presentation. Questions, please.
Hi. Do you provide any asset classification services at all? Identification and asset classification?
Yeah, good question. So from this data, do we provide any classification? So vegetation versus built up, is that what you're asking? Yeah, so today we provide the data in the forms that I talked about, doing the classification, say identifying building footprints, identifying pervious surfaces versus impervious surfaces. We don't do that, but we know of a number of companies that do those kinds of classifications. It is kind of the obvious thing to do. The other obvious thing to do is actually do change detection. Because you've got these captures done on a regular basis, if a building wasn't there last year and is there this year, it's quite easy to kind of do a change detection comparison.
When you look at the oblique imagery in products like Google Maps, there are often lots of artifacts in there and the data isn't terribly clean. How on earth do you quality assure all that data and get such nice imagery?
Good question. How do we quality assure? One of the fundamental tenets of Nearmap is that we believe in fully automating the process, so kind of taking humans out of the process. So if you look at it, humans only are involved when they fly the plane, take the hard drives out of the plane and put them in a FedEx pack or equivalent, or an Australia Post pack, and send them back to our offices where we plug them into the cloud and off they go. So the whole process of stitching all of those pictures together into what you see as an ortho image or an oblique image is fully automated. Now, over time, over the last 10 years, we've really optimized that process. So it's rare to kind of see artifacts, but and the other piece of it, as I said, is we collect so many pictures of one point on the ground that it's easier to do the reconstruction.
How many years of data do we have in the database?
Yeah, so the database for Australia, the longest is about 10 years old. Now that's a Perth capture. But for most of the cities in Australia, it's 8 years of capture. So again, if you're a major capital, if it's a major capital city, there's probably about 50 or 60 captures over that period, 6 times a year. For regional areas, it can be a little less, but again, kind of 8 captures for there. And then in the US, we've been capturing for about 3 years.
Oh, 20 shots at a point. That's really awesome.
Yeah.
I have a question for you. Why Nearmap? Why can't other companies do?
Yeah, it's a good question and kind of correlates to the question before about how do we not have artifacts in our imagery. We're a technology company at our core, and we've invested in building our own camera systems. So most of the other companies that are out there that capture this kind of content use off-the-shelf camera systems. They're good, but they just don't collect the quality and content of data or an amount of data that we do. And that fundamentally then drives the quality of our product as well as the process that we reconstruct all of our imagery from.
Awesome. Thank you, Rob.